Okay, so I'm back, and as I mentioned earlier, that I will be doing a variant for this question, which is a little different, but still up the same logic has been applied. Let me start the timer for 15 minutes, and the question would be this. So you're given an array of pairs of dominoes and an integer target. Return the number of unique domino pairs A1 and A2 and B1 and B2, where A1 plus B1 is equal to the target and A2 plus B2 is equal to the target. Okay, so we are given a dominoes, which is an array of pair of integers. So it could be like 11, 10, 9, 10, 10, 12, 1, 2. And it also says that an integer target. So target could be, let's say, like 10. Um, so in this case, we have to check if we are comparing these two tiles, then 11 plus 9 equals target, and then also 10 plus 10 equals target, which is 20, and 10 plus 10 is also 20. But right now the target is 10. So we compare this with some other element in the dominoes. And the way to go about this could be like for every domino tile, we compare, like, actually, let's just do 20 as the target. And few questions would be the domino, unique domino pair. Um, if duplicates, if duplicates, do do we count it again? And other question would be, so digits. Every domino pairs has digit, right? So right now we have to figure out the digit. I forgot to ask initially, digit range. And I think this example would be wrong just because usually dominoes are from 0 to 9. And for this, I assume it's 0 to 9. And if duplicates, yes. And unique domino pairs, no. So we can, instead of that, we can do 9, 1, 1, 9, 1. And target could just be 10 here. Here it would be 8, 2, 7, 9. So in this, we know there is only one pair. That, and if suppose, let's say there was 1, 9 again here, then we know that this 9, 1, the pair would be 2. So the answer would come out to be 3. Answer would be 3. Because if we check 1 and 9, then we see that these two pair is 1. And then with this, there is 1 9 comes 2 times, so we count it twice. So that's why the answer would be 3. A brute force way would be to go over every element. So we start from index 0 here, and then we'll check if there exists a pair in this one. If however much many are there, we count it and store it in the answer. Then we go to this pair, and then we check again, and then this pair, and then we check again. So here the time complexity would be around O of n. square, which is obviously we can do better than space, would be O of 1 because we're not using extra time. Um, then we can do a little bit of optimization where we can try to get the time complexity down to O of 1. As we use the logic of like hash map, so we can have a hash map, right? And that would be equal to this, and then we can add 1 9 in the hash map and with at index like actually this would be 1. So this hash map would look like um domino and domino and the times it occurs. In Python, we can just use the domino as it is in a tuple format. So domino can be just be a tuple. But since here there is only 0 to 9, right? Like the range of the domino. So what we actually here, digit range is only 0 to 9. So maybe we can just convert this into a number, which would be like 19. So we can just do 1 into 10 plus 9. And it'll store, so what it'll store is 19 comes 1. Then when we go over 9 and 1, that is 91 comes 1. And while adding to the hash map, we just increase the count by the frequency count, by the frequency that already exists for that specific number. Let me unique dominoes. And here we are giving an input as dominoes, which is a list of int. And we are also doing target, which is an integer, and we are gonna return an integer. And we could use the tuple in this one, but this would be a two-pass solution as we are converting into tuples first and then checking the hash map. And there is a better approach just because the digit range is only from 0 to 9. But if it was the other case, then we can just use the tuple format. And here the time would be O of n and space would also be O of n because we're going to be storing every dominoes until we find like go through the entire array of dominoes. Okay, so hash map is equal to this. I could just use a default tick so I don't have to deal with missing keys. And for give me 1 second. And we're gonna be, yeah, so for dominoes, Actually, we can just use like a helper function, get digit. Define get digit, and it will take in the tuple, the domino. And here we're doing, let me just do that. And then the logic would be for domino in dominoes. If domino in hash map, then we need an answer variable, right? Because we're returning the number of values, like how many pairs are there, plus equal, answer would be equals to 0. And if dominoes in hash map, then answer plus equal the value that is so hash map at get digit domino. Actually, if not domino, if complement, right? We have to find the complement in hash map. Then we'll do answer per hash map at complement because that is the value. And here complement is so the complement would be target minus domino A and target minus domino B. This would just be A. Let's to get A1, right? We have to get A1 and A2, which would be domino. So to get the digit, what we'll do is we'll return domino at 0 and multiply it by 10 plus domino at 1. And this would return an integer. And here we're passing the list event. So we get A1, A2 as domino, and then we can just use like convert it back. Actually, so we can just build a set of unique domino digits, right? But that would not make sense. So I think this could be for A1, A2 in dominoes, and we could just do like complement is target minus A1 and target minus A2. And then We could get like a current key, which would be the digit, is equal to digit. I mean, you could just do on the fly instead of pre-computing it, just because that'll save time. Not, and also, oh well, timer is up. Let's do another 5 minutes. Started for 5 minutes, and we can just do a1 into 10 plus a2. And if the complement, like this key in hash map, then answer would be equal to that. And otherwise, we will add it to the hash map. Hash map current key equals plus equals 1. This we don't have to worry about if it does not exist, and at the end we just return the answer. Let me just quickly check. So here we have to check for current key, not complement. And let's do a quick dry run. Example can be, so dominoes can be this. We can do like 3, 4, 1, 9, 3, 4, 2, 1, 9, 1, 9, 1, 7, 6, and maybe 1, 9. Okay, so this is the dominoes that we have. And let's start the dry run. So answer is currently at 0 and hash map is empty. Okay, we come here at this domino. Now we do, and let's do target as like 10. Target equals 10. Okay, so we are at dominoes 3 and 4. So we did not need this function, so we can get rid of it for now. And now we check for complement. So complement becomes complement equals target, which is 10 minus a1, which is 3, and 10 minus 4, which is equal to 7, comma 10 minus 4, that is 6, 7, comma 6. Now I'll check if the current, and then we convert this into a key. So that would be 7 into 10 plus 6, which is equal to 76. Does it exist? No, so we just add 76, comma 1. This is how we add. And then this does not execute. Now we move on to the next domino. 1, 9. So we check for complement for 1 and 9. So 10 minus 1 and 10 minus 9, which will give us 9, comma 1. Does it? And now we convert it into digit, which will give us 19. Does not exist, so add that to the hash map. 19, 1. We come to 3, 4. So we'll do 10 minus 3, 10 minus 4, which is equal to 7, comma 7, comma 4. 74 does not exist. So 74 is added. as 1. Move it to 1. So 10 minus 2, 10 minus 1, which is 8 comma 9. That's 89. Does not exist. So we add it. Answer is still at 0 because we have not found any key. Now we move forward. Wow, timer is up again. Let's do another 5 minutes. Okay, here we are at 9 comma 1. So 10 minus 9, 10 minus 1, which is 1 and 9, that is 19. 19 exists. So we will add that frequency. That is what we'll get. And we add 1 here. Now, actually, let me just 0 plus 1. But does 19 exist, right? So we will also have to add. Actually, did I do it wrong? I think I did the dry run wrong. We have to not convert this. We have to convert this, like just 4 and 3 is for 34 into the answer. So this would be 34 is 1. So we add 34 because that is what we're doing here. A1 and A2, not the complement. Then we come here, that is 19. That's what we add. Does not exist yet. So 34 already existed, right? No, so let's do the dry run again. So 10 minus 3. First, let's just put 34. So that's 3 into 10 plus 4. Add it to the hash map. Yes. 34 add to hash map. Now with the complement, now complement. Which is 10 minus 3 and 10 minus 4. That is 34. Then we also check for complement. And yeah, so 34 comp key would be, yeah, and this is 7 and 10 minus 4, 6, 76 is the complement. Now 76 does not exist, so we just add 34. And then at when you were here, 19, so that would be 1 into 10 plus 9, that's 19. That does not exist, so we add that 19 and 1. 19 and 1, now we are at 34. So 34 occurs twice because that key already existed, and then complement is 10 minus 3, 7, and 4, 10 minus 4, 76. Not yet, so we move on. Then we add 21 once, and we will check for the complement, that is 8 and 10 minus 1, and 89 does not exist, so we'll move forward. Now 91 occurs once, and then we check for its complement, which is 1, and 10 minus 1 is 19. 19 exists 1, so we add plus 1 to the answer. And then 91 now occurs twice, plus 1. So that could be it. Also, the assumption was it can have multiple pairs, but cannot pair with itself, cannot pair with itself. Now 76. Okay, I think we got the gist, and this would come out to the correct answer. I'm gonna end this video here, but I think it was not that great. We'll try again. Thanks for watching.